Thomas Scott, NotAMs Ecosystem API-enabled interoperability. So take it away. Thanks, Thomas.
Thank you all for joining. We're going from a very macro level view of what's going on with respect to interoperability and Agile to a micro level view of what's going on in the Boeing Company, especially around NotAMs. And I'm going to start off with a quick introduction of myself. I'll give an outline. I'll make sure to explain what a NOTAM is for those of you that are not familiar with it, and talk about what we have in the past and what we're doing in the future. So first, about me. I am the NotAMs Ecosystem Product Manager. I've been in this role about 2 years. In the past, I've worked on a couple other Boeing products called Onboard Performance Tool and Interactive Quick Reference Handbook. OPT handles takeoff and landing. IQRH is the emergency handbook that pilots use if something goes wrong with an airplane. Prior to joining Boeing, I was at CDI Aerospace, Goodrich, and Spirit AeroSystems. I'm actually a nacelle and power plant expert, not necessarily a digital expert. So this has been quite an interesting role. Education, have a PhD in aerospace engineering, an MBA, and I'm presently in Washington, D.C. doing the International Business and Policy program at Georgetown. So I really have tons of spare time. So here's the agenda for today. I'm going to start off by explaining what a NOTAM is. I realize some of you may exactly know what this is, but I imagine there are 25 or 30% that have no clue what a NOTAM is. Next, I'm going to explain why they're a problem. I'm going to start out with a real case of a flight operations risk. Perhaps I should even call it issue because it occurred. And then I'm going to talk about the National Transportation Safety Board perspective on NOTAMs and data overload. And then next, I'm going to talk about our interoperability solution to try to address the NOTAMs problem. That's our Smart NOTAMs ecosystem and our Smart NOTAMs solution. So that is the agenda for this morning. So first, what on earth is this thing called a NOTAM that I keep referencing? It stands for Notice to Airmen, and it's essentially a telegram. It's in all capital letters. It's extremely cryptic. It comes into our system actually through telephone lines, and we then distribute a lot of these, around 4.2 million a year, to users all around the world. So a Notice to Airmen, the concept is over 60 years old. It literally goes back to the days of telegram, and it's information pilots need in order to safely fly. And a lot of information they don't really care about at all. So sometimes I tell people I'm in charge of the garbage department, and my slide on the NTSB will provide more color behind that comment. So this is an extremely simple NOTAM. I took this from our database. This is one for Denver International Airport. All NOTAMs have an issue date, start date, and end date. Here you can see it's at Denver Airport, has a specific number, has a time effectivity from May 17th to December 18th, and effective area 16 left, 34 right is closed. This is an extremely simple NOTAM. You'll notice that we have a few formats, plain language, which I chose here for this audience. There's also an ICAO and domestic format. I'm not going to go into the details here, but we maintain this in multiple levels. So this is a plain language NOTAM. So what is in these things called NOTAMs? Well, the information is extremely varied. It starts with the trivial. I'm in downtown Washington, D.C. I can see all these tall buildings around me, and they have flashing lights on them. Every once in a while, one of these lights goes out, and because we're in the United States or in a world that's very legalistic, someone decides to contact the airport and they issue a NOTAM about a flashing light out on a building. In this particular flight path into Washington, D.C. Reagan, it does have more importance than in most locations. So that starts with what we call the trivial. Then we go to the awareness, grass cutting times, birds in the vicinity of airports. I mean, if you think about this, birds are generally in the vicinity of airports. Some places get really innovative by describing the type of bird that's in the vicinity of the airport. I mean, you may think this is odd, but it matters a lot if it's a Canadian goose or a flock of sparrows. It really does make a difference. Then you get to the important closed runway. That can be very, very important. And I won't go into talking about the incident in particular, but if you Google Canada Air 759 into San Francisco International Airport, that's a situation where the airplane crew, due to fatigue, missed a closed runway and almost landed on 4 other airplanes. So there's very, very important information buried within trivial, simple awareness information. The other key component is, when is this effective? So the one I showed you was extremely simple, closed from a current day to another current day. And generally there's an hour there. I just kept it very simple for this slide. The complex is effectivity combined with criteria. So I just kind of pulled something up in common language. So limited by wingspan less than 20 meters on the second Tuesday of every month between 6 to 8 p.m. and 4th Thursdays between 6 to 8 p.m. NOTAMs can have extremely complex effectivity, especially at major airports like Chicago O'Hare and Frankfurt or London Heathrow. So this is the type of information we're dealing with. How much information are we dealing with? So this is the history of NOTAMs arriving from 2017 to 2021. And you'll see that we're currently in the orange line and we're lining up right with 2019. We're going to hit about 4.2 million NOTAMs this year from sources all around the world. So in general, NOTAMs are relatively predictable. Winters have NOTAMs, which increase the frequency, but every once in a while we see something like this. This was the ice storm that hit Texas in February of this year. So there can be specific events that cause a noticeable spike in the number of NOTAMs in a given month. So my team processes all 4.2 million of these a year. We have a high rate of automation. We have numerous internal checks with both computers and actual people to ensure the information going to pilots is correct. So now I've sort of told you what a NOTAM is. I've told you how many we have. Next, I'm going to talk about where they're used. And this gets important from the case of interoperability. So NOTAMs start out in flight planning, and I've listed some of the Boeing Jeppesen products here. You may not be aware of what these products are. I'm not going to focus on them. I'm just listing them here because they're in the slide I grabbed from another deck. So we start out in flight planning. So before you get to your airplane, several days before, there's someone at the airline who's trying to figure out where this flight is actually going to go, what areas do I need to avoid, what are my backup airports. So this is pre-work at the airline. And you need to know the NOTAMs because you need to consider runways that might be out, restricted airspace, anything that could affect the safety of your flight. After the flight planner is the dispatcher. The dispatcher reviews the flight plan and updates it for any current information. That is occurring 4 to 6 hours before a flight. Finally, flight preparation. About 2 hours before a flight, a pilot goes into the briefing room. They get either a digital copy of NOTAMs, or some airlines still give them paper copies of NOTAMs to review, along with everything else in their flight plan. And we've done studies that show that pilots spend 7 to 11 minutes reviewing NOTAMs for a given flight. To give you an idea, a standard domestic package of NOTAMs is likely to be about 60 pages. So what the pilots are really doing is looking for anything that they haven't seen before. So generally, for taxi out, takeoff, the pilots are heads up. They're not looking at the NOTAMs, but they're relevant for the safe operation of the airplane on the airport tarmac, on the taxiways, on the runways. And obviously for takeoff, you want to avoid anything that could be dangerous for the aircraft, such as a crane close to construction close to the airport. That's the most common thing to be aware of. En route, generally at 30,000 feet, there are not a lot of obstacles. However, there are places called temporary flight restrictions and special use areas. A very simple example is when the President of the United States is somewhere, that's a temporary flight restriction. You can't go there. I don't care who you are. Well, if you're a military airplane, you can fly the zone, but all commercial traffic is out. Finally, when you come back to the airport, sometimes nothing happens during your flight. Other times, if you're on a major 8-hour international flight from, say, Frankfurt to Atlanta, you've taken off and everything is fine in Atlanta. There could be an incident at the airport while you're in flight. You need updated NOTAMs in order to safely land. A runway could be closed due to an incident that happened at the airport. Could be a weather incident, could be a flight-related incident, could be a ground support equipment-related incident. Finally, you have to get safely to the gate by driving around the airport. In the summer, there's a lot of construction at airports you need to be aware of. And finally, at the very end, the headquarters will look at your flight, compare it to the information, and the FAA does have reportables for any airspaces that are violated or any time that you've violated a restriction. So there is an audit process at the end. So NOTAMs come into play for every aspect of the airplane operation, from flight planning all the way through after-action reviews. So why are they a problem? I'm going to start out with an example of a real situation that occurred, and I talk briefly about the NTSB perspective, and then finally how we're solving the NOTAMs problem. So this is the Jetstar Manila NOTAMs issue. You can see what happened to the Jetstar 737. Oh, there it is. I didn't expect that to move. Let's see if I can go back. So the airplane got off the runway due to missing a NOTAM, and where they're supposed to go is here. But there's a NOTAM showing this part of the runway was closed, and they ended up here, and they tried to do a 180-degree turn. There's quite an interesting commentary if you actually can get the air traffic control recording. It's relatively complex to play recordings on the WebEx, so I didn't do that, but you're welcome to Google the Manila incident. It's quite interesting. So, of course, what happens after the incident? There's a new NOTAM that results. So now it's closed to a stalled aircraft. So the immediate impact was a last-second go-around to an airplane that was trying to land on the same runway, and this was way too close. There was a canceled flight. Obviously, since the front tire was stuck in the mud, this flight was not going anywhere very quickly. Increased controller workload and airport personnel, quite a strain on an operational airport to close a runway, reroute traffic, route ground control equipment, and then support equipment to safely move passengers off the airplane and back to the tarmac. That's quite a bit of work for the airport. Again, the passengers were bused to the terminal. We had 6 crew and 140 passengers inconvenienced and delayed, and an 8-hour runway closure. So our potential idea is, what could have helped avoid the incident? So obviously the flight crew missed a NOTAM. We proposed that having something we call airport movie map with integrated graphical NOTAMs and on-ship display would have reduced the probability of this incident occurring. Again, I just sort of listed the long-term consequences. Obviously, someone had to pay for this 8-hour closure of the primary runway. That would be the airline. Damage to the airport surface. People disagree on how much damage there was to the nose gear, but it definitely had to be inspected. And of course, there are airline public relations concerns because this is extremely easy to Google. So this is a cartoon of some technology that we're working on. We actually have airport movie map that currently exists. What you see in the red box is something we call smart NOTAMs. We're able to geo-encode a NOTAM and place it actually on the airport map. So for certain, this is a cartoon to make it very easy to see and to keep our IP safe. But this is what we're working on for incident avoidance. So it's important to note that this plays into interoperability because NOTAMs are somewhat siloed. Certain aspects of the Boeing Company have easy access to them because they've been plugged into the system for 25 years. New concepts, new areas of the NOTAMs, new areas of the Boeing Company would like access, or people outside the Boeing Company would also like access. So to go into the public commentary on NOTAMs, this was a quote from the National Transportation Safety Board that NOTAMs are just a bunch of garbage. So hence that is my unofficial title. I'm in charge of garbage for Jeppesen Boeing. Erica Armstrong is a pilot in the Denver, Colorado area. She also teaches at Metropolitan State University. She has these 2 wonderful graphics that we have permission to show you, where she has her NOTAMs for an international flight laid out, and I believe this is domestic flight. So she says this very well. you're looking for birds of Bangkok, war and peace by Greece and Turkey, unlighted tiny obstacles, goat grazing times, and grass cutting times. The humor here is that Greece and Turkey complain over airspace jurisdiction in the global NOTAMs feed. Pilots don't want to read international politics in the NOTAMs feeds. So this is the challenge we're up against. And these are a few of the more fun quotes from Robert Zumwalt, who is the chairman of the NTSB. The NOTAM system's really messed up. They're a bunch of garbage. They're written in some kind of language only a computer program would really understand. So this is the challenge. So now I'm going to talk about interoperability and how we are using it to try to solve the NOTAMs problem. I'm going to talk briefly about our ecosystem and then our solution, and hopefully leave time for questions. So this is a picture of our ecosystem. So we feed many internal products off of a legacy system we call eNOTAMs. We have a Jeppesen NOTAM distribution system that feeds internal and external systems. We have our NOTAM management tool, which is our current operational system. It comes along with a dashboard that allows the airlines to actually go in and choose what NOTAMs their pilots see, in what order those NOTAMs are shown. For example, if you're a commercial airline, you're really not concerned about parachute jumping, so you ask NMT to filter out all parachute jumping. And NMT operates on the ICAO classification for NOTAMs. And this is, we have to push this on to the airlines for liability concerns. It's very hard for Boeing Jeppesen to design a filtering system. This is good for NetJets, FedEx, and say Delta. We just can't devise a system that puts everything in the right order for everyone. All of our customers have different needs, so we built the system that enables our customers to make their own choices. And there are also a lot of legal reasons we have to do that. We're building something called NOTAM Cloud Service, and that's how we get to interoperability. It's our new cloud-based delivery system that is able to feed both internal and external customers via RESTful APIs. And this is a real change from a system that is really built only to serve Boeing customers or with direct connections through TCP connections to a fully cloud-based modern interface that's able to serve multiple Boeing customers and also external customers. So just for an example of what you're dealing with, this is what an example NOTAM looked like in our legacy system. It was actually a character-based system where whereas the text was just running text, and the first 11 characters were reserved for NOTAM number, the next 2 for Jeppesen version. This is really out of the 1970s, early 80s Fortran world. We're trying to get away from things like this type of presentation because it is very backward. It is not the way technology works today. You definitely need a secret decoder ring, and it is not very user-friendly. So this is our next generation system. We have our NOTAMs processing, where 4.2 million NOTAMs come in a year. We have our NOTAM management, where querying, searching, sorting, filtering, and alerting occur. This is all cloud-based. The NOTAMs delivery, again, is cloud-based. And finally, NOTAMs use. We use it primarily in flight planning and on our flight deck, but we have been reached out to by many internal customers at Boeing, and we also have requests from external customers, all the way from airlines to flight aggregators who are interested in incorporating NOTAMs into their operations. And one of the newest areas that is reaching out to us is the UAV market. Some of you may be aware that you have to go through a LANC system with NASA and the FAA in order to fly your drone. I don't think many standard home users are doing it, but you're supposed to go register all of your drone flights. And that uses temporary flight restrictions in special use areas, which are NOTAMs. So this is the future ecosystem where everything moves to the cloud, commonly displayed. We've got internal and external systems, and this is where operability really comes into play. We're taking a system that was very valuable but very isolated, and we're bringing it into a very positive, very forward-thinking modern system with cloud-based APIs. And we think this is going to be a game changer for getting information out of silos and to our worldwide NOTAM users. So again, this is all based on modern API accessible data. The primary ways that people interact with us are flight-based searches. So you're flying from Atlanta to Frankfurt and you want to know the NOTAMs at the arrival and departure airport. You want to know in-route NOTAMs, and you want to know NOTAMs at any airports that are backup airports or emergency airports for ETOPS. Attributive-based searches, you're looking for NOTAMs at a particular airport under a specific condition. So let's say you're a dispatcher and you've got a flight flying Frankfurt. It's already been planned. You just want to make sure there are no new runway closures at Frankfurt. You would do an attributive-based search for runway closures at Airport Frankfurt. And then we have a generic API delivering customer-specific data. And this is our way of opening up the ecosystem even more. Thinking about people and users that are not just looking at it from the perspective of the airplane. Maybe they're looking at it from the perspective of planning what gates are going to be available for an airline in the future. Or users we don't even think about because we're really airplane oriented. One area is what the airport needs to know. The airport is issuing NOTAMs, but maybe they want to use our system to get it distributed across the airport because it's newer and more efficient. So what we're after is runway visualization and geoencoding. And these are the things we're looking at: runways, limitations on runways, taxiway limitations, what we call TFRs and SUAs. I mentioned those earlier. Customer NOTAMs. Airlines can issue their own NOTAMs to their own team. We can manage that. And then some smaller airport features like stands, stop bars, runway approach lights being out, and aprons. So yes, there are physical markers at the airport, but we also provide all this information digitally. And this is a quick example of what it will begin to look like in a real EFB device. This is on an iPad. And essentially, at a very high level, this is Waze for airplane pilots or Google Maps. You can see information about a runway partial closure or a runway schedule closure right here graphically in front of you based on the interoperability with data, with NOTAMs. So again, it's all about supporting routing by ground operators. Those are flight planners and dispatchers. And then it's viewed on the flight deck by pilots. What we're after is one data lake that supports all market segments. So that's what my picture is of here, a generic data lake. And we support commercial, military, business, general aviation, and just off to the right, our friendly little drone. And we're used in basically plan, dispatch, fly, and also in the analysis phase. This is an overview of where we're going with data interoperability. And this, in closing, is a wonderful NOTAM to show you the cryptic nature, and I'll take any questions.
Thanks, Tom. Great job. So I'm just looking through the questions here, and we've got a couple for you. And one is kind of more of a different aspect of this is NOTAMs to airmen. Is there anything out there like that NOTAM to passenger? You know, so it's kind of like, hey, I'd really like to know if, is there anything out there that tells passengers that, hey, maybe you should delay your travel or go a different route or something?
I love that question. As someone who used to fly once a month to Frankfurt, I would love to know what's going on. I'm not aware of anything that is specific using NOTAMs. I know there are companies like FlightAware and others that will let you look at history for a flight, how frequently it's delayed, and you can see it as it travels across the country. It's very cool. I'm not aware of plugging into the worldwide NOTAM system to passengers that, a part of a taxiway is going to be closed or runway is going to be closed. The airlines themselves have notifications, depending on what airline you fly. I get text messages from my airline about flight delays, but they've never told me about a runway closure at an airport I'm going to. I do wonder if that might scare some passengers to know the logistics going on in an airport. But it's a good question, and right now, no, NOTAMs are not being used in anything that's going directly to the passengers.
Okay.
There is talk about using it in chat between pilots, being able to put NOTAMs into chat.
Okay.
Those would be private chats.
So we've got another question here. This has to do with data interoperability, and the question is, have you selected certain data interoperability standards for structuring your NOTAM content going forward? If so, what are they?
Yes, internally we are XML02 and externally we are GeoJSON. And beyond that, we follow the, ICAO has standards about the labeling and the data fields. So we are JSON following the ICAO standard.
Okay. So what about interoperability with other systems? I mean, that's probably how you internally consume and externally exchange information. But does the NOTAMs information utilized by other systems?
Yes, yes. We are utilized across the Jeppesen ecosystem. We have a symbiotic relationship with the mapping department. NOTAMs are on a 28-day, what's called permanent cycle. So if a NOTAM is more than 28 days in effectivity, it will actually be placed on the map layer that goes with Jeppesen mapping and charting. NOTAMs are also sent to the runway analysis teams so they can update information on particular runways to make sure that it's safe for pilots to take off. They are shared with our flight planning department, so it's integrated into their older through WixD and newer through a NOTAM management tool, flight planning. So if you're using Jeppesen flight planning, you're directly plugged into our NOTAM system. Our modern tools like Aviator and Flight Deck Pro also get the same NOTAM feed. So we are we're integrated, but our challenge is we're integrated in very much a spider's web of varying levels of technology and varying formats. A big aspect of our NOTAM cloud service is to take us to a modern API interface with JSON format, RESTful APIs, and everyone is able to get the same data by using the same type of API calls. I mean, obviously, this is a tough transition for some customers that are plugged in the system for 25 years. They would like to stay where they are. It's a lesson in change management, but our objective is to move everyone into this forward-looking system and keep everyone in a forward-looking system so we do not have this spider's web.
Okay, because that's an interesting concept that maybe people aren't familiar with commercial aviation. Maybe it's the same in the defense world, I don't know, but is this technology transition, today we talked about digital transformation and industry transformation, but one of the interesting phenomena about commercial aviation is you have multiple technology generations you have to interface with. The paper in the box or paper in the file cabinet all the way up to, like you have here, an iPad, right? So
right.
How does Jeppesen respond to that? Are they required to support all generations of technology, or what's the strategy for that?
This is an extremely difficult challenge. And Jeppesen doesn't get to be the arbiter in all cases because we have customers. And our customers, many of them have built systems that are reliant on our data arriving to them in specific formats through specific channels. So we have to have a cooperative and synergistic approach to make sure that we're not endangering or taking any of our customers into areas they can't go. Especially during COVID, the staffing has been decreased by our airline customers. So this is a very, very careful and tricky situation to navigate, both internally and externally. We don't get to be the arbiter. We are under a massive effort to increase the cloud utilization, increase our ability to survive HADR events, and to basically be responsive to the industry's needs to provide information without any disruptions. However, I'll just share, for those of you that don't know, the FAA at Norman, Oklahoma, part of the NOTAM processing office is 3 stories underground in a basement. They were doing construction. They dug a hole outside the building, and a thunderstorm came through, like a tornado thunderstorm, and filled the hole with water. And that leaked into the FAA's basement, and we lost that feed for 8 hours. So we are not the only point of vulnerability in this large system.
So you like that working area problem, huh? All right. Hey, we have one more question. We got another question that came in for you, Tom. This has to do with, so forward-looking, crystal ball time, right? Polish that up a little bit. So the question is, what standards for data need to exist to support the future state of the ecosystem around NOTAMs?
ICAO has a good standard. The real problem is, and one of the reasons my team historically exists, is the anarchy of states. Since I study international business and policy, I finally get to slip this in. ICAO has no teeth. If you are a nation state and you do not issue your NOTAMs per the ICAO standard, so what? You know, there's no fine. You know, ICAO has no boats, no guns. They're not going to go invade your country because you issued your NOTAMs incorrectly. So this is a purely voluntary system. It would be nice if we could get a stronger coherence to the ICAO standard, but this is extremely hard. I mean, just yesterday, North Korea launched missiles into the Japanese airspace area, and there was an agreement 3 years ago they were supposed to issue a NOTAM, and this agreement was with ICAO, and they did not. So we were up against the anarchy of states. What my team does is they standardize all the input that comes in. That's really what that very left-hand side does. It takes people who did not write a NOTAM well, whatever the problem was with the NOTAM, and they get it into a standard that can be absorbed downstream. So we are the standardization for all the Boeing customers, and we standardize to the ICAO regulations. But nation states, that's a free-for-all.
Excellent. Hey,
all
Tom,
right.
got a question. I got a question kind of on the future state. I've been working the last 3 years with autonomous vehicles, and I was fascinated, you know, with your presentation on this notice to airmen. But how is that going to play out when we have autonomous vehicles, auto taxi, auto land, auto takeoff? They need to know all this information. You know, the FAA is working the air traffic control next gen. Have you kind of thought about what that's going to look like in the future?
So I've seen several presentations by NASA on this, and generally it's referred to as microflight planning. So, you know, if you look at macro flight planning or normal flight planning, it's between airports. Microflight planning, my understanding of the definition, which is I'm not on the NASA committee, is it's between two locations that are geographically defined and they are not specifically airport locations. So you're going from a roof of an office building to an office park or to a downtown restaurant.
The vertiport space, yeah.
Right. So this combines what we have with what others have. So the National NOTAMs Ecosystem, or National NOTAMs data from the FAA, contains information about temporary flight restrictions in SUAs. In a place like Washington, D.C., pretty important. You don't want to bust an airspace. But for most of the rest of the country, if you're flying around in a micro zone in a city, other than height restrictions that are on any urban area, there's probably not a lot of NOTAMs that are actually going to affect you. Unless you're getting near, say, there's a government complex on the west side of Denver, Colorado. They are probably covered in a very macro level NOTAM. Another one is there's one NOTAM issued that basically defines controlled airspace around major sporting events like the Super Bowl, etc. We presently do not intake that information. We don't have a way of getting information about every major sporting event occurring in the United States or the world. So the NOTAM is out there, but we're unable to take that NOTAM and take it to cover every sporting event happening in the United States. And that's the challenge that you're going to run into with microflight planning is these NOTAMs are issued and they contain the instruction, but the instruction is so broad, such as you can't fly less than, I forget what the regulation is, I'm going to make it up. You've got to give at least a 5-mile lateral circumferential airspace to a major sporting event, and you've got to give it 20,000 feet, unless you've got special clearance. How you're going to take that and translate that to every sporting event in the country, it's going to be a really big challenge. I know companies are looking at it, and we hope to be part of that solution. It's part of a market study of where Boeing plays in this new space.
Right. I think there's a huge opportunity there, though, and especially as we get vehicles talking to other vehicles, and because we're doing work now with air traffic control and just taking the radio communication and translating that digitally and being able to interpret it. And I see the NOTAMs being that kind of it's going to have to be translated so that it can be consumed when there is no airman, right?
So the biggest challenge we have right now is there's all sorts of really cool artificial intelligence and machine learning that people are studying. But the challenge is we have to be able to tell regulators the rules that are in play. And that's the beauty of the system we have. It generates defined rules based on the ICAO standard. If we have artificial intelligence that's making a decision, something goes wrong, the FAA is going to ask for the list of rules the AI used. To my present understanding, AI is not very good about giving you the list of rules. It's good about giving you its answer.
Correct. Yep.
So that is a regulatory and legal hurdle that we have to overcome, not just in NOTAMs world, but in the aviation industry, in order to really strategically bring artificial intelligence and machine learning into the daily operation of major commercial, military, and civilian air traffic control.
Maybe that's a topic we can have at another time around trusted AI.
Love to do it. Thank you.
Yeah.
So Tom, we've got 2 minutes left here. One more question that has come across is there a method or so you have this data lake of NOTAMs information. Is that being mined? And is there any predictive or prognostic approach to NOTAMs based on historical and current environmental situation that's being looked at?
We do save all of our NOTAMs to a special location that is mined by the R&D team in Frankfurt, Germany. However, there's not been a lot of conclusions that have come out of it that have directly affected our ecosystem. Primarily, our focus right now is the modernization of the system to make sure that it is fully interoperable, and hopefully that will give opportunities for others, both within the Boeing system and in cooperation with Boeing, to access the data and figure out how to optimize flight path, things like that. We have several endeavors within the company that look at NOTAMs and that have looked at NOTAMs for optimizing flight paths. So there's much work that can be done. The question is, of all the things you can do between, say, putting a netting to reduce drag and noise underneath the front wheel well of an airplane to using NOTAMs to reroute the airplane, what is the most efficient way to deal with CO2 emissions and community noise regulations? And right now, NOTAMs have not stepped up to the forefront as being the most impactful solution.
Okay, interesting. Thanks.
I wish they were. That might get me like more people and more money. So, got ideas, send them.
Great, thanks, Tom. We got that. Final note: more money, more people, right?
There you go.
Great
Absolutely.
job, Tom. Very interesting.
Yeah.
Just fascinating. Absolutely fascinating.